Okay, section 3 is on solving systems using adding or subtracting. So what you're going to do is you're going to add or subtract, and what that's going to do is eliminate one variable. Then you're going to solve what's left. So we have one variable, solve the resulting equation for the only one that's left. And you're going to substitute in either to find the value of the eliminated variable, so one you got rid of in the first step. Okay, so what I'm going to show you is just how to add every time. It says add or subtract, but we're just going to add every time to keep it consistent. What you want to have when you set them up like this is for all the variables and the constants to line up, and then what you want is one of the coefficients to be the opposite of another. So on this first one we have 2 and -2. So all you have to do then is add everything straight down. So 2 plus -2x cancels. 3y plus 5y is 8y. 11 plus 13 is 24. And then we need to solve this equation for y. Divide both sides by 8, and y is 3. And then you're going to substitute in to either one. I'll say the top one because there's no negatives. 2x plus 3 times 3 equals 11. 2x plus 9 equals 11. 2x equals 2. X equals 1. So our solution is 1, 3. So when they say to use subtraction to eliminate a variable, they're just saying, hey, look, the y's are both 3's. But what I'm going to do is I'm going to multiply one of the equations by a -1 so that we can stay consistent and add every time. So if I multiply the top one by -1, that's -4x minus 3y equals -2. And then I can just be consistent and add every time. 5x plus -4x is x. The y's cancel. X is -4. And then I'm going to substitute that back into one of the originals. I'll say the top one. 4 times -4 plus 3y equals 2. -16 equals 3y plus 3y equals 2. 3y equals 18. Y equals 6. Okay, so this one, they don't have everything lining up right away, so what we need to do is move the variables around so that the x's and the y's are all lining up. So I would have to subtract the 3x from both sides and then put it in right below the 8x. I'm going to actually rewrite the whole thing to make this a little easier. Okay, when I have everything lined up, we can see that the y's have the opposite coefficient, so we can just add down right now. 5x equals 10. X equals 2, and then plug that into anything. Now, I'm probably going to plug it into the original right here, actually, since it's almost already solved for y. 4y equals 3 times 2 plus 14. 4y equals 20. Y is 5. Our answer is 2, 5. Okay, I'm going to go through and silently work on these. And I just showed you how to go through the first two. I'm actually just going to write down the answers for the remainders, and you can go through and do the work if you want to have a little bit of extra practice. And we'll go to the last page for the word problem. During a kayaking trip, a kayaker travels 12 miles upstream in 3 hours, which is against the current, and then 12 miles downstream in 2 hours, that's with the current. Find the average speed of the kayak in still water and the speed of the current. Okay, so this one's a little tricky. We need to find out what the speed is when he's going upstream and when he's going downstream. So we're going to use the distance formula to do that both times. Upstream took 3 hours, which means he was going 4 miles per hour. And going downstream, it took 2 hours, which means he was traveling 6 miles per hour. So now we're going to set up two different equations. First one is for upstream. We need to find out what the speed of still water is. Not of, speed in still water, how fast that he's going. And when we're going upstream, we have to subtract off that speed of the current. That's going to be equal to the speed of the kayak. And I'm going to do a similar situation for the downstream. We want to know what the speed in still water is, but this time we get to add on the speed of the current because we're going faster, going with it, and that's going to be equal to the speed of the kayak. So we don't know either one of those things, but we do know what the speed of the kayak is, and that's our rate. Upstream we're going 4 miles per hour, downstream we're going 6 miles per hour. So now we can use elimination to find out what x is first, because the y's have opposite signs. If I added straight down right here, I'd have 2x equals 10, which means that I am going 5 miles per hour in still water. And then I'm going to plug that 5 into either one of the equations. Put it in the first one. 5 minus 4 equals 5 minus y equals 4. So y is 1. And that's our third section on solving systems of equations using elimination.